Good morning, everyone. As the technology advances, people get more hands on digital content. And to store this digital content, we need a lot of space. Now, rather than increasing the storage space, we can reduce the file size of this digital content. So, this is exactly done by this algorithm, which is image and video compression. This is the image compression algorithm. So I'm going to explain it. So this is the image I took. So first this is fed into the compression algorithm and it is divided into macro blocks. And then we apply discrete cosine transform to each of these and then we quantize it. So when we are quantizing, it's a lossy compression method. The high frequency part of the DCD blocks uh, will be removed, and because of that, when we reconstruct the image, the contrast has gone down. The hard color changes have been, it has disappeared, and if you can look closely, the edges they are smoothened out. And another method I use to reduce the size of this image is run length coding and Huffman encoding. The reason for that is we can reduce the coding redundancies caused by when we are storing the image in digital format. So the compressed image, we obtain compression ratio of 1.3, and the video coding, we are going to now next look into video coding. I use this architecture to model my algorithm. So first we have a frame 1, we store it as it is, and then we try to predict the rest of the frames using this frame 1. So this is the frame 2. Now we have to predict frame 2 using frame 1. So I use motion vector estimation, motion vector array. So to obtain this motion vector array, I use sequential search algorithm. And this is the motion compensated image. Now if we only store the motion vector array, this is what we get. But to obtain the expected desired image, we need to add something to this, and that something is residual. We can obtain this from by subtracting the estimated image, the motion compensated image, from the actual second frame, and then we quantize the residual to reduce the size a bit more, and then we only store the motion vector array and the quantized residual. So this is the reconstructed image we obtain from this, and the compression ratio for this is 3.6 as 3.4. And now we are going to look into quality analysis part, where I use 1 over PSNR as my distortion metric, and as you can see, when the quantization level increases, the distortion reduces, and the optimum point for the quantization levels to operate is at 8. And some of the problems I faced uh, during this project was that selection of quantization was not optimum. I took the quantization matrix from internet. It's a standard form. Was not optimum, hence the pixelated output is obtained. From the graph we can see that the best, I explained that point. And then another problem I faced was in the quality analysis part, and to quantize the DCD blocks, I used level quantization, it is not the standard quantization matrix that you can get from internet. So I use MATLAB's inbuilt function, which is imquant, for this to quantize it to a specific number of levels. But this MATLAB function is limited to specific number of levels, so I can't go beyond that. So because of that, I try to code it by myself, and then the problem was that Huffman encoding library, its dictionary in the inbuilt Huffman encoding function, and its dictionary is limited to a certain number of values. So this is the link to my portfolio. You can find the full project codes and everything there, and even a video, the compressed video and the quantized video. Compressed video with quantization and without quantization, and quality analysis. Up to everything you can observe from this link. Thank you.